Fine, guys, let's start. Okay. So yesterday we have started with the feature engineering, right? And we have seen the high level overview of different feature engineering techniques. Okay. So today we are going to study feature scaling in detail. Okay. So my screen is visible, right?
Santosh.
Okay. Fine. So see guys. So yesterday I have already told you like why feature scaling is important. Okay, and it will be mainly much more important for the models which will be dealing with the distance measures. Okay, fine, like linear regression or KNN or K-means or mostly with the deep learning models. Okay, so we have seen a simple toy data example. Fine. So now let's try to actually see what are the different ways of feature scaling techniques that are available. Okay, as I said, mainly there are two-way standardization, normalization, and we will try to see standardization in detail. Like as I said, we'll understand what is a formula. Okay, and what does it actually mean when you try to standardize the data. Okay, what happens with the geometric intuition and with the code example. Okay, and then some general points. Okay, and then we will be seeing the same thing for the normalization. Okay, fine. So to start with, okay, so as I said, these two are techniques to scale the data, guys. That means what? Simple, bring the given columns into some common scale. Okay, fine. Now in the standardization, what happens? The word itself is saying that you need to standardize the data. That means what? If you remember statistics class, we discussed two things. One is normal distribution, and other thing is standard normal distribution. Can one of you tell me what are the properties, fundamental properties of a standard normal distribution?
The mean value should be
Mean should be
0 and standard variance should be 1.
great. Okay, so mean will be 0 and standard deviation will be 1, right? So that is standard normal distribution. So this is also a normal distribution, but it has some special type of normal distribution where the mean will be 0 and standard deviation equal to 1. Fine. So now let's say over here we are having some data set age and salary. Okay, so now first of all, if you see, age is in the completely different scale. Okay, range, or in salary is in some completely different scale. Okay, so and the scale is also very different. Okay, it's not that age is in some 20s and salary is on 30s. No, it is in some 2 digits and it is some 5 digits. Okay, which is completely different scales, and obviously you need to scale this data. So now if you use standardization, what does it do? Means it will take each of this column. Okay, for example, it will take age column and then it will standardize this. That means what? It will convert it into a corresponding column, which will, let's call it a standardized age, such that the new column will have mean equal to 0 and standard deviation equal to 1. Getting? The original age mean is some 37 and standard deviation equal to 6. Okay, from the raw data. Now once you apply standardization, the meaning is it will convert it into a standard normal distribution column. That means the new column will have these properties. So the new column, which is standardized age, will have mean equal to 0 and standard deviation equal to 1. Getting? And how we can do that? We already know to convert this column into standard normal distribution. So you need to do x minus mean by standard deviation of x. Okay, that means what? What is this mean of x? That means if you take age, then this will be mean of age, and this is standard deviation of age, the original standard deviation. That means, for example, if you see, are you able to see this inverted data? Turn it. Okay, fine. So I will just do it and show you. So over here it is saying, for example, to calculate the value, standardized value of this value. Okay, what is actual value is? Or actual value is 35. Agree? So the value will be 35. Okay, minus what is mean of x? That means mean of this age column. So it is 37.42. Okay, so you need to do 37.42. Okay, and then you will have standard deviation of this. That means 6.88. Give me one second. Sorry. Let me change the mouse. 1 second. Yes, guys. Okay. So now, yeah. So if you see, the value is for 35. Here x will be x 35 minus 37.42 minus what is standard deviation 6.88. Okay. Then you need to put it as 6.88. Okay. The what are the value we are going to get is equal to 0. Sorry, it is minus 0.35 something. Okay, this is the value we are getting. So that in that way, you need to apply this formula for each and every column so that you will get the corresponding standardized column. And this standardized column will have 0 and 1. Same thing what we already studied in statistics class. Getting same thing for the salary also. The actual salary mean is the standard deviation equal to this. And once you use this formula for each and every value over here, you will get this corresponding standardized salary. Okay, with the mean of 0 and 1. This is how you are doing this is also comes under feature transformation. That means what you are creating new columns from the existing columns. Okay, and this is how you can do the scale. And how did we scale? Now earlier this range is something, this range is something, but once you do this, the ranges will be from -3 to 3. You remember, because standard normal distribution according to empirical formula, you remember, or you just forgot everything? Over here if you see, and then you have yeah, so when any normal distribution, the data will be most of 99.9% of the data, 99.7% of the data will be available between mu minus 3 rho plus mu plus 3 rho. And what will be this mu in standard distribution? 0. So it will be from -3 to +3. Getting over here also, now the overall data will be between -3 to +3. So you have brought the these two columns into some similar range. Getting is
Yes, Santosh.
okay, fine. So this is one way how you can do the standardization. Okay. Now, next thing. Now, what happened? So if you just try to visualize what is happening in the geometric in the when you do standardize some data. So what is happening? So I'll just give you an idea. For example, let's say. Okay, so this is your age column, right? So when you say age column, so if you scatter these values, let's say you are scattering, let's say it is available over here, sorry, it's scattered over here. Okay, and the salary column, okay, and the salary column, let's say it is scattered somewhere over here. Okay, because its range is different. Now this data age, okay, the age is having some, it will be having some mean. Okay, it is having some mean. Okay, and mean is what the average value. So somewhere over here, the middle value will be some mean. Okay. And its standard deviation will be something. That means the spread of the data will be something. Okay. But now if you the salary, its mean will be somewhere over here, the average value. And spread will be something. Okay, the raw data. But now when you standardize this, what's happening is when you standardize this, if you try to understand, now what is the mean? Mean is 0. Getting that means the age. Okay, the age is also this is 0, right? The age will be spread over here because the mean will be 0 and standard deviation will be equal to 1. Agree? Now salary mean also became 0 and standard deviation is also 1. So that means its spread will also be over here. Getting? So we brought both of them into same scale almost. So if you see geometrically, you can understand earlier they'll be scattered very far away in the space. Agree? Because its mean is different. Its mean is different. Standard deviation, the spread is also different. But now we are able to squash them into very similar values because now the age and salaries mean is also 0. That means this will be 0, right? Origin. Fine. And that means the average value will be 0 for both of these values. And standard deviation is also 1. That means spread is also 1. Okay. So this is how you can visualize what's happening when you do the standardization. Okay. So now we are creating equal importance to both the columns. As I said, the model's job is to tell us which column is more important. But when we are sending, we should not be biased. Okay. I am creating equal importance. I am bringing them into same scale. Okay. And almost similar values because both of the range will be -3 to 3. So there is no way model to misinterpret that one column is greater than another column. Okay. So I am giving equal importance. Okay. After model building, model will let us know whether the age is contributing more or salary is contributing more. Okay, fine. So the takeaway point here is just what is the formula you need to use it for the standardization and how does the columns look like. Okay, and also if you remember, because the values will range from -3 to 3, so that's why you see some negative values also. Okay, fine guys. And now let's jump into the code example. Okay, too much theory we have seen. Now using some code, I will show you what is like how you can do feature scaling and what happens if you don't do feature scaling, and is it always necessary to do feature scaling. Okay, these 3 points if you see practically, I think you will get good understanding. Okay, but before that, any doubts guys, the theory part or till now? Let me know. I'll give 5 seconds. No? Okay, so let's start. So over here we are having let me take my pen. Okay, so over here I'm importing the basic modules. Okay, and I am considering this data set. What is social network ads data? Okay, so what it is saying, it is having a user ID, it's saying the gender, age, salary, and whether he has purchased or not. Okay, fine. So now from here, what I'm taking, I am considering only these 3 values. Okay, so as of now, I'm considering only age, salary, and the label target value. Okay, so how I'm going to do that? I'm taking all rows but columns from 2 to the last. Okay, and this is my data set. Okay, so age, salary, and purchased. So and after that, see, before doing scaling, so first of all we will split the data, guys. Okay, practically when you see, we'll split the data. As you know, we have seen in detail the splitting of the data. Okay, so we will have the train data and we'll have the test data. Okay, first we'll split the data. Now you will take this training data, okay, and we'll apply the scaling. Okay, and whatever we are applying to the training, we'll do the same for the test also. Okay, same type of techniques you need to use it for both the training and testing. Okay, fine. So we have split the data. How we are splitting using the train test split. Okay, and this see, we need to pass both x and y, right? So the train test split, what you need to pass? You need to pass x and you need to pass y. So how you are passing x? If you see df dot drop, so from this whole df, if you are dropping what I'm dropping, I'm just dropping the purchased. Okay, I'm just dropping this. What are the left? These two are left. Okay, age and estimated salary. So these two are obviously my x. These two are my features. Okay, so this is another way of passing. You can also do df of, you can take two brackets and you can say age comma estimated salary. You can also do that, but instead of writing two names, I can just drop one name purchase, so that I'll be left out with other two names. Okay, you need to specify access equal to 1. Okay, and this is x, and df purchased is my y. Okay, so I give x and y, and my test size is 0.3. That means training size will be 0.7. Okay, and random state is in hyperparameter. And if we have not discussed, we'll be discussing this. Okay, but x, y, and test size we have given. So it is divided into this. My training size is 280 rows and test is 120. Okay, total 400 rows I'm having. Now, obviously, you know, x train, y train will be my training data, x test, y test will be my test data. Clear? And we will be using this x train, y train for scaling or training or any training purposes. So now what I have done, let me proceed for the scaling. So we have seen till now, I would say theoretically, standardization. The way how you can import standardization is from the sklearn. So as I said, everything whatever you need regarding the ML, but at least for basic models will be available in the sklearn library. Okay, from sklearn.preprocessing, import standard scalar. Okay, import standard scalar. That's it. Once you import, you create an object of standard scalar. How do you create? You just do this parenthesis. Okay, you will get the object, and now scalar dot fit. Okay, scalar dot fit. I'm fitting it on x train. Okay, but here there is an important point. If you observe here, this is my scalar object. Now I'm fitting it on x train. Okay, that means what? What does this line mean? I'm fitting it on my x train means fitting its what? Means what? It is almost called as training. Okay, even in our machine learning sample also, if you remember what we are doing, we are just saying model dot fit. That means learn. Okay, do the training, learn the logic. Same thing also applies over here. When I do scalar dot fit of x train, that means fit means learn. Okay, that means it will learn the parameters over here. If you see, right, so what type of values it should create? That means this logic, guys. Okay, so whatever the calculations it is doing, okay, calculating the mean, calculating the standard deviation, and applying this formula, this logic it will learn when you do the fit. Okay, once it has learned, I'm using the same object over here to transform both my x train and x test. Okay, this is an important point. Okay, there will be two things. One is fit, one is transform. In simple words, fit means learn. Okay, fit means learn, and transform means apply. Okay, but here the point is you will learn it from only training data set, and you will apply that learning to both training and test. It's not that you will learn from both training and test. No, you are learning this what need to be scaled and what is what are the values you need to scale on. Okay, that you will learn it from the what training data set, scalar.fit. You are doing training, and with that you will be using to transform both x train and also x test. Agree? Because x train and x test are from the same column, right? Are from the same column. You have just split it. It is only one age column. You have cut it into two. One became train and one became test. Agree? So that's why you will learn it only on the x train. This is how you do learning scalar.fit. And after this step, this scalar object, initially this is just empty scalar object. Once in line number 6, it has understood what the scaling. Okay. With this scaling, you will just do scalar.transform on x train. It has learned on x train. You are applying it again on the x train. Okay. Here it is just learning. Transform will apply. Same thing you're also applying that x test. Okay. So Earlier you have xtrain, xtest. Now you have xtrain scale and xtest scale. Now these are scaled values. Clear, guys? Any doubts?
No, Santosh.
Okay. Okay. So that's how you need to scale it. So it is as simple as this. Okay. Whatever we have studied theoretically, right? It is just 2 steps. Okay. Import the scalar, just create an object, just fit, transform. Okay. Now you got scaled. You are just scale your data. Okay. And if you see, yeah, now if you see when it is scalar dot mean, okay, that means what? This is my scalar object, right? So when you do scalar of mean, so it is giving you the mean of both the columns. Okay, in my scalar, I have 2 columns. One is age and one is estimated salary. Okay, it is giving the mean of age and also mean of the estimated salary. Okay, now what is the mean of this? It is, if you see E plus 1, okay, 3.01. Okay, so before you scale, and after you scale, let's see the mean values. Okay, so for example, see here, this is my xtrain. Just remember, xtrain and xtest are before scaling values, and xtrain scaled and xtest scale are after train values. Okay, so xtrain are before values. Okay, and xtrain scaled are my scaled values. Okay, so if you see these values, age, estimated salary, what are the values you are having? So these two are the, and this is for age. See, this is for age and this is for my estimated salary, corresponding standardized values or scale values. Okay. Now, but this is a numpy array. As you can see, this is a numpy array. But earlier we are having a pandas data frame. Okay. So just to convert this numpy array into pandas data frame, so I've used simply pd.data frame. Okay, create a data frame from this xtrain scale. Okay, and the columns will be my xtrain columns. Okay, what are the columns? These columns, the actual xtrain columns I'm using, it will use these two. It will just attach these column names to this numpy array. That's it. Okay, nothing fancy. So xtrain, xtest. Okay, so now if you see xtrain scale, these are my xtrain scaled values. Okay, these are my xtrain scaled values. Okay, as you can see, we have applied standardization. That means the values will range from -3 to +3 with a mean of 0 and 1. Okay, so that's why you will see some negative values. Okay, some positive values like that. Now, if you see, as I said, once you do the standardization, it will create new columns such that the mean will be 0 and standard deviation will be equal to 1. Earlier, it will be different values. Okay, before scaling, that means only xtrain values will have some mean, some standard deviation, but xtrain scaled will have 0 and 1 values. Okay, we'll see that. Okay, you know, describe function, we know a simple pandas describe function. Okay, so over here, if you see clearly, you'll get a picture. So this is on xtrain, only xtrain I'm doing describe. Okay, this is just np.round means it will just round off the decimals to 1 value. Okay, so what focus here, and this is a xtrain.describe. That means before scaling, the raw data xtrain describe I'm doing, and this is xtrain scaled describe. Okay, this means after applying the scaling, that means after standardization. Over here, if you see the age column, the mainly we will focus on mean and standard deviation. So mean is some 37 and standard deviation is 10, and estimated mean is some 69 and standard deviation is 34. But here, if you see, after scaling, after applying standardization, the mean became 0, standard deviation is 1 for age column, and similarly, mean is 0, standard deviation equal to 1 for estimated salary column. Okay, that's how you can also confirm that you have applied standardization scaling. That means you have converted this age column. Okay, what is the age column? This column. Okay, this new column which you have created is in a standard normal distribution form. Okay, that means the distribution will be like this. I'll show distribution also. Okay, this, and mean will be 0, standard deviation equal to 1. Same thing. So you brought both of them into equal scales. Is this clear, guys? Can you see these values? Understanding something?
So Santosh, directly, so if you do transform, it will directly apply standard normal distribution. That's it, right?
No, no, no,
For
no,
scaling purpose.
no, 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 no. What you are,
Scale. Okay, yeah. Standard as scale. Okay, okay.
yeah, you
We
are
have
applying
used
this.
object.
If you
Okay.
use some other, yeah, on that object you are doing, man.
Yes,
If
yes,
you
yes.
use some other standard scalar, you will create that and you do transform. Okay. The
Okay.
concept is just not about the scalar. The concept is whether if you use any, let's say you're using some other new scalar, something. Okay. We'll create new
Hmm.
scalar object, new scalar
Yeah.
object. But the point is you'll fit it on training. Okay. This will be new. This will be new. You'll fit it only on train. That means you'll learn it on train. You'll apply it both on train and test. Okay, fit
Yes.
once. Simply they will say fit once, use any number of times. Okay.
Yes.
Usually they say fit once, use again and again. Okay, we'll use again and again. So you're fitting here, you're learning on train data. That means it will understand, it will learn what is the range, how much scaling I need to do. Okay, what is a see guys, what is happening over here? So if you understand when I say fit, okay, what it will learn, it will learn for this logic. And here what I need to apply to convert any value into standard or the corresponding standardized value, and I require mean and standard deviation. Agree? If I know these two values, simply I can take any value and apply this formula. Agree? Do you agree, guys?
Yes, Santosh. So
Now,
here,
huh,
for mean and standard deviation, it will take entire
correct,
complete data set value.
correct, correct. So with that values, it will take, and then with the same values, it will apply for the training data and also
Testing data.
test data.
Because all are comes under single column.
Correct, correct.
Okay. Yeah.
So that's why it will fit once, learn once, and apply transform. Any scalar if we use over here, so it will just use, it will fit once and transform again and again. Okay, fine. So over here, yeah. So is it clear is, so how the values are getting transformed to standardized values? Others getting?
Yes, sir.
Okay, fine. So now we got the values. Okay, we have done the scaling. Cool. But before Karthik, any other doubt you have?
No, Santosh. Fine.
Okay. So now if you see the effect of scaling, okay, we have just plotted the data. Okay. So I'll share this notebook. It's nothing. So we have used so everything what we are using is using over here, we have already studied. Okay. So we have studied the subplots, we have studied this AXI, taking the axis, scatter, set title, scatter. Okay. So using that, we're just plotting the data. Okay. The age and estimated salary before scaling, and age and estimated salary after scaling. Okay. So if you see, the data is same. The important point here is same amount of data is present here and here, but just by looking here, you don't see much difference. Okay, but the only thing that is changed is the range. Okay, so here the range is some values, but here if you see, the mean value became 0. Okay, the middle value somewhere it is 0. The mean of these values is 0 now. Okay, but here earlier the mean was some value 30 etc something. Getting the mean is some 37.9 age. Okay, so over here some 37.9 will be the mean value, but here the mean is 0. Even by visualization also you can understand. Okay, and if you say the distributions, that is also important way to understand. Okay, because when I'm saying I'm doing standardization, that means what? I'm converting it into standard normal distribution technically, right? Before the distribution might be different, but now how it is looking. Okay, so see, I don't know whether you're visualizing, but after scaling, both of them becoming almost same range columns, right? So that means both of them will behave in similar way, guys. Okay, that means why? The mean and standard deviations are bringing to 0 and 1 for both of the columns. Okay, so the age is also over here, standard deviation is also over here. When these two values are same, that means the average value is same and the spread is also same. That means most of the properties will be same for these two columns. Okay, so that you can see. So for example, if you see over here, before scaling, if you see this, if you see the distribution, the age and estimated salary are like this. Okay, why? Because if you see, when you're plotting, yeah, this is a problem. So one more problem, if why why you should scale is, let's say if you're not scaling, okay, so you're using the same data, and if you visualize, see this blue color is age, and this yellow color, can you see this yellow color? It is like overlapping with the x-axis, right? So that is your salary. Why this is, and this is very hard to understand, because the scale of age is very different and scale of salary is very different, and because salary is ranging from till like some 75,000, okay, or 7,50,000, okay, or 75,000, fine. And but age range is very, very less. That means usually it will from 0 to 100 max. Okay, not 0 also. In our case, I think some 20 to 80 its range is. Okay, that means see, the first bin itself is from 0 to 25,000, and from here if you consider because we are plotting age and salary on the same scale, okay, and if you consider 0 to 20 to 80, it would be very, very small, okay, and in that if you try to plot the distribution, okay, it will be almost a straight line. Getting? But if you, and similarly if you go for the salary, in the salary the values are almost different from each other, okay. The age, there might be some common values. That means like 3 people might have what do you say, like age of like 50, and 2 people might have age of 25, something like that. But coming to salary, most of the values will be unique, and if you see, every value is different from each other, and the scales are extremely high, okay. And if you see, the range is still here, okay. The maximum value is could be 75,000, but here the maximum value is, it will be 80, which is almost near to 0 because of the scale, okay. And that's why age is happen to look like this and salaries look like this, okay. From this you cannot estimate anything. Agree? We did not, why? Because we did not study any of the properties regarding this distribution. Fine. That's the reason, as I said, whatever we studied stats will be useful over here. Fine. Why we are going for scaling? Because if we don't scale, if this is our data, we are having these 2 lines, and what to do with these 2 lines distribution, we don't know, we did not study. Agree? So we studied everything about the distributions, normal distribution, standard normal distribution, or some other types of distributions, okay, not about lines. So that's why we always try to convert this into some distributions which we have studied something about, okay. So and why did we study? Because that are the mostly available distributions over there. As I said, normal distributions is one of the most commonly available in nature, okay. From there we have deduced standard normal distribution, okay. So that's why instead of working on this, we will try to standardize and convert it into some known distributions, okay. Now after standardization, if you see, the age is looking this, and salary is looking this. See, almost similar. As you can see, both of the mean is 0, okay, and standard deviation is equal to 1. That means the maximum values will be ranging from -3 to +3. Getting, guys?
Yes, Santosh. But can you please go to above plot, that scattered plot?
Okay.
I mean, this is before and after scaling, right? Why again the data points like those are look similar?
Yes,
I mean,
that's a very important point. So now the point over here is the date. See, that's the point you need to understand. See, whatever the variations are there between each and every point in this scale, the same thing will be maintained in this scale.
okay, got it.
Okay.
Range should be yeah.
The
Okay.
range is different. It is ranging from 20 to
Yes.
60, but but it is ranging from, let's say, -3 to 3 or -2 to 2. But the variation between each point in this scale will be same
Yeah.
for these 2 points. That's the reason you can scale, because
Yes.
I thought anybody will ask this question, that how we are able to scale. Like these 2 columns are, see, this column is completely different from this column, okay. So this value is ranging from what? The age is actually some 20 to 60 something, okay. How you are converting these values to -3 to 3? and this range is some completely some 5-digit numbers, how you're converting it into -3 to 3. That means the fundamental point here is the variation between each and every point that is available in this scale will be maintained in this scale. So that's why if you see practically when you plot a graph, the plots, the data points will look exactly the same. Okay.
Yes.
So if in this scale from 20 to 60, if these 2 points are this much nearby, the corresponding distance will be maintained over here in this scale. The values will be very, very different. Okay. But the variation between the points will be same. So that means the variation will be maintained, whatever the scale you take. Okay. But the scale will be different. Similarly, if you go for the age also, yeah, the age and estimated salary, both the points, right? So similarly, if you take for other columns, it will look the same. So the variation will be maintained. The scale will be changed accordingly.
Yeah, sure, Santosh. Thanks.
Okay, fine. And this is the plotting, guys, and this is a distribution. Okay, so there are like multiple ways I am showing. Okay, so one is from direct code level, you can directly see using the describe, and using the plotting the data points you can see, and using the distributions also you can see. Okay, and you can also go with individual scale distribution also. And individually, if you see the age before scaling is this, okay, 10 to 70. Its mean is some 37, and it's ranging from 10 to 70. And but after scaling, the range mean is 0, and standard deviation is from -3 to 3. Okay, fine. And same thing goes for what is it, salary, and this is ranging from some value. Okay, but after that it will come to 0 to -3 to 3. Okay, so that's one more important. And now if you see the scaling importance, okay, now fundamentally whatever we do, whatever we learn, ultimately should help us in some accuracy, building the accuracy or getting better model. Agree? If not, why we will do? Now, if you see using this data like age, salary, and what is the output column purchased, whether it's 0 or 1. Okay, let's try to build a small model and we'll see whether the scaling is helping us or not. Okay, so now this is my model. Okay, logistic regression model. So as I said, you don't need to understand logistic regression model because we not study this yet, but just understand this is a simple ML model where given two inputs, okay, it will understand the logic and it will try to give some predictions. And how it will do predictions, let's forget it for a while, ignore it for a while. But I think you know the process. Like we will be passing training data, X train, Y train. Okay, and after that, for the model, you will be passing the X test. Model will give you the Y pred. You will compare it with the Y test for the predictions. Okay, I hope this concept, the train to split, is clear. So let's see, you are importing the model, okay, and you are creating the model object. Fine. And same model object, I'm also using one more model. Okay, why this for scaled? Okay, now on this LR is my logistic regression. I'm fitting X train, Y train. Okay, I'm using my X train, Y train, the unscaled before scaling values. Okay, and on this X train scaled and Y train, I'm fitting it on another model, LR scaled. Okay, are you guys getting or getting confused? See here, LR is one model, LR scaled is one model. Model in the sense what? These are just simple logistic regression models. Okay, that means I'm just creating one plain LR. It is not, training is not yet done. Okay, training is not yet done. I'm just creating an object of this model. Okay, using the same logistic regression, LR is one object and LR scale is one more object. Okay, as of now, LR and LR scale will be both are same because the training is not yet done. Okay, you can create any number of objects of this model. Okay, once that is done, I have LR scale. On this LR, I am fitting this model. I'm fitting it on what? I'm fitting it on X train, Y train. Okay, the basic data. Okay, raw data. I mean, without before scaling, X train, Y train, I'm fitting LR. Now this LR scale, I'm fitting it on what? I'm fitting it on trained data X and Y. Why we will not train? Okay, remember always the training will be on features, guys. Okay, only on the features. That means X. The Y will not we will not scale. Okay, it will be just the raw data, whatever you do. Okay, so now over here you're having X train scaled. Okay, what is X train scaled? Scaled data. Okay, that means it will have both age and feature. This will also have age and salary. This will also have age and salary. Okay, but this is scaled. Okay, done. Now after that, simply you can get the predictions. Okay, using this LR, you can use X test. I'm getting Y-pred. Okay, and now this LR scaled, on this I'm passing X test scaled, not X test, because as I said, I'm repeating again, this is very important point. When you scale it on train data, you should apply the scale it on test data also. Okay, usually what people do, they'll take the data, they will try with different types of scaling methods. Okay, on training data, one thing will work best, they'll use that, but on the test data they'll forget, they'll apply the same data, the raw data. Obviously it will not give best results. Because why? Because as I said, when you are training it on something, okay, you are having a model. Okay, you are training it on some data. Now while testing also, it will expect similar data. That's the whole point of training, right? So to train, to allow the model to learn something, so that when you give similar values after training, it will try to give some predictions. Okay, so that scaling should be maintained. You cannot train on some like thousands, ranging between thousands while training, and while testing you cannot pass some decimal values. Okay, so it cannot learn, because while training it was seen something, but while testing you are asking something else. Okay, if you don't want to scale, remove it from both training and test. But if you want to include, it should be for both training and test. This is very, very important, guys. Otherwise, the whole thing what you're doing on scaling is no use at all. Okay, so over here, if you see, over here in the first point, when I'm using it on X-train and Y-train, simple X-train, Y-train, okay, this LR, I'm using that to predict only on X test. That means here also I did not scale, simple, that here also I'm using unscaled values. Getting, I'll clear and I'll show you. Okay, this is X-train, Y-train. When you're using, use only X test. Okay, similarly, for the scaled model, LR scale, if you're passing X-trained scale and Y-train, while prediction also you should use scale data. That means X test scale I'm using. Okay, from here I'm getting Y-pred. From here I'm getting Y-pred scaled. Are we clear till this point? Everybody, any doubts?
Yeah, clear, Santosh. But little confusion, that's it.
Sir, repeat again.
Repeat. Okay. See, guys. Here we are to show you the difference whether scaling is helping us or not. What we are doing here is two things we're doing. One is I am creating LR. This is also logistic model. LR scaled is also a logistic model. Okay, this is also logistic model. Okay, but the training data which you are passing is different. On this LR, what we are doing, I am passing just X-train, comma, Y-train. Okay, see this first line, X-train, comma, Y-train. Okay, just first we'll see only this. That is done. Once training is done, after that, what we can do, you can do it, you can use the model for predictions. Now, what is my model? My model is LR. Okay, over here it is LR model. Okay, we are passing X-train, Y-train. Training is done, and what predictions I'm using, what? X test. Well, predictions I'm using X test. The model is giving me Y-pred. Same thing till we studied. Are we good till this point? This one?
Yes, sir.
Okay, fine. Now this is the raw data. Now I have created one more model, LR created one more model in the sense what? I created one more object, LR scale, the same logistic regression. But for this, if you see what I did, I passed, okay, now remove this. Okay, now for LR scaled, okay, this is my another model. I am passing this X-train scaled, okay, X-train scale data I'm using, okay, and Y-train I'm using. Okay, fine. You pass X and Y, model gets trained. Okay, now while doing predictions, what I'm saying here is while doing predictions, this step for this LR scale model, while doing predictions, okay, guys, these two are, see, don't think that these are like related to, like I would say, each step is related to the previous step. I mean to say, over here, if you see, this first step is for LR model. Okay, this first step is for LR model. Okay, the second step is for LR scaled model. This second step is for LR scaled model. Okay, so you're just combining this process and doing it in one shot. Okay, so don't think you should do it in one shot. Okay, you can just do first, you can fit this and then get the prediction. Okay, and then fit this, get the prediction. Okay, I think if you're getting confused, I mean to say, see guys, you can also do this way. Okay, for example, if you just want to complete one, okay, we are doing one thing, right? So I'm saying take this model, okay, just fit on the LR, okay, and just do the prediction on LR. Okay, this is your LR model. Okay, this is your LR model if you're getting confused. Okay, and now LR scaled model, what we are doing, you can also take the initialize this LR scale model, okay, and now do this, then do this. Okay, so if you're getting confused with this thing, okay, so you can just see this. Okay, this thing is this. Okay, this is this LR model. You have created the model and you have used the training X-train, Y-train, predicted. While predicting, you passed only X-test. Okay, X-train, Y-train, you passed X-test, you got Y-pred, Clear this one?
Yes, Santosh.
Now, if you see LR scale, yeah, tell me. Okay.
Sir, Y-train values we do not scale.
Why? Oh, sorry.
Y-train values ni scale చేయము sir.
No, we will not scale the values because what is the Y scale values if you see here? What is the output values we are having over here? 0, 1. Agree?
Okay, sir.
What will scale this? Okay, and usually will not scale because see, Y is just for the predictions. Whatever you learn from the features. Getting whatever thing you are going to learn, you learn from the X value. Okay, based upon the X value, you predict Y. Y you are not going to touch most of the time. Okay, mostly if it is categorical, it will be like 0 or 1 or some other values. Mostly you will do some encoding that we will see. Okay, but scaling you will not do. Okay, mostly you will apply only to the features. Okay.
Okay, sir.
Fine. So now see here, this is an important point. We need to understand this. So this is plain LR model without any scaling. So if you want to just divide X-train, Y-train, you'll do fitting, you'll do predictions by predict, that is fine. But now if you focus again, I'm taking the LR one more object called LR scale. But here what I'm passing X-trained scale and Y-train. That means I'm passing X-trained scale and Y-train scale data I'm passing. Okay. Now that is fine. Now while I'm doing the predictions, what I'm passing, I'm not passing X-test. See, earlier I passed X-test, but I'm passing X-test scaled. Why? Because this model is trained on scale data. So I should pass scale data only for predictions. If it is trained on only basic simple data without scaling, I should pass only X-test without scaling. While training, if you are training it with scale data, X-test scale, you should pass for predictions also X-test scale. So that's why if you remember, we did fit transform. We did transform for both X-train and Y-train. Agree? We did not do it for only X-train. We did transform for X-train also. We did transform for X-test also. So we have transformed it. We just kept it ready so that we can use it for these predictions. Okay. So earlier you got X-test, Y-pred. So similarly you will get here you are passing X-test scaled. Okay. You are passing X-test scale. And the model will give you Y-pred scale. Clear?
Yes, sir. Clear.
Yes,
Clear,
Santosh.
right? But the important point here, very, very important point over here is the actual Y test. Okay. If you remember the actual Y test, that means what? X-train, Y-train is over. Okay. And X-test you are passing. Here you are passing X-test scaled. You are getting Y-pred. You are getting here, sorry, this is Y-pred scaled. Okay, fine. But what is left? Y test is there, right? The corresponding actual value of this X test, you will have Y test.
Yes, Santosh, that we will use for comparison, right? With
That
white,
we
right?
will use for comparison. But important thing is, it will be same in both the cases. Okay.
Correct.
Y test over here, and here here also it is Y test, because why? That is
Yes.
actual value. Fine. So you are going to compare this value with Y test. This is also with Y test. Why? The point you need to understand over here is the scaling, whatever you are doing, that is on the input features. Okay, but you are not touching the Y. Fine. So whether you do scaling, whether you do any other technique, I don't care. While testing, ultimately you need to test with the Y values, and those Y values we are not touching. It is actual Y value. Okay, so here Y train you have used. Okay, but the corresponding Y test which will be there with this X test, that will be same. Okay, so in the plain model you got Y pred, that you will compare with Y test. Okay, getting that you are going to compare with the Y test. Over here in the scaled also you got Y pred scaled. This is also you are going to compare with the Y test. Okay, because if you see, try to understand, guys, what is changing over here. Y train will be same, you're not touching Y. Okay, only X train is changing. That means here the X train will be actual values, here X train will be scaled values. Okay, and here X test will be the actual values, here X test will be scaled values. Okay, now Y pred, you see here this is Y pred, this is Y pred scale, but this does not mean this Y pred is scaling. Okay, this is just the name which we are giving. Don't get confused. Here I am giving Y pred scale just to understand that these are values are coming from a scaled model. But that does not mean that this Y pred is scaled. That means this Y pred will also be having 0 or 1, 0, 1, 1, 0 values. This Y pred will also have some 0, 1, 0, 0 values. So I mean to say just some categorical values, whether it is 0 or 1. Because predictions, right, guys? This is just prediction. Whether you do LR predict, LR scale dot predict, ultimately these are predictions. And what is it? It will predict the output variable. And what is output variable? 0 or 1. Agree? So whether this Y pred will also contain zeros and ones. Okay. Y pred will also contain zeros comma ones. Y pred scale will also contain zeros comma ones. Getting?
Yes, Santosh.
Yes.
Or lost? Lost somewhere?
No, sir. Understood.
Okay, fine. See, the last point I'll tell you. See, just give me 2 minutes, you will understand everything. Okay, see, what I was saying here is training is done on input features. Okay, so that means over here you are while passing input features, you're passing the trained values. Okay, while passing test also you're passing test scaled values. Okay, scaling is done. Okay, everything is done. Now here you are passing, here you are asking. Okay, here you are passing X test and you are asking predictions. Okay, the model is giving you some predictions. This Y pred, I'm giving the name. This is a variable name. You can give anything. Simply I'm giving Y pred. Okay, this here the model is doing predictions. What predictions it will do? The Y, see here, the Y pred predictions will be what? Let's say it is having 0, 0, 1, 1, 0, 0. Some it will be obviously 0 and 1s. These are predictions from the model. Okay, now over here you are passing train values. Okay, now you are getting Y pred scaled. Okay, now the Y pred scaled. Okay, this is also predictions. Obviously this should also be 0 and 1s, but where you will get 0 and where you will get, there might be some difference because of the scaling. Okay, because of the scaling, if the scaling is helpful, so obviously you will get some better values. How you will know whether it is better? Let's say you got here 0, 1. Okay, 1, 1, 0, 0, for example. Okay, obviously these both will be 0s and 1s because that are the ultimate prediction the model should do. Okay, but now you might think, what is the difference? The difference is you will get when you compare these two with the what? With Y test. Okay, with Y test, which is the actual value. Agree? Which is the actual value. Y test, this Y test. Fine. Getting, guys? See, what's happening over here? What's happening over here? See, don't get lost. See, over here, if at all you are having the actual y test, see, if you're having actual y test, the values are, let's say, 0, 0, 1, 1, 0, 1, for example. Guys, are you there?
Yes, sir.
Okay, now see here, you will understand here. Now let's say the actual values, the actual y test values. That means what, guys? This value, this y test value is this value. Now our goal is the model predictions. Okay, the model predictions. Okay, the model predictions should be as close to these values. Then only the accuracy will be high. So what I'm saying here is, so if you see this, we are having two things. One is y-pred, one is y-pred scaled. Agree? One is y-pred, one is y-pred scale. What does this mean? This does not mean y is getting scaled. It only means this y-pred is coming from normal x-test and these values are coming from scaled x-test values because we are passing scaled input values. Okay. So now here the point here is, if you are having y-pred, let's say y-pred is getting some values. Let's say you are having 1, 1, 1, 0, 1, 0. Okay. This y-pred is values are this. Okay. Now if you see y-pred scaled, okay, y-pred scaled, if you are having like 0, 0, 1, 1, 1, 1. Okay, these values will be different, guys. Okay, whatever the predictions which you are getting, okay, that will be different because when you scale the data, you might get some better accuracy. And how you can say, see here, for example, here over here, if you see, you're having 0, 0, 1, 1. If you compare with only y-test and y-pred, see, you're having 0. So see, you're getting the point, right? Ultimately, whatever you use, whether you use the direct y-pred or whether you scale it and get y-pred scale, or you use some other scaling, then you will get y-pred scaled, new other scaling technique or some other scaling technique. Each of this model will give you some different values. Ultimately, whatever you come up with, that should match with this y-test with maximum possible values. Then only your accuracy will increase. That is our whole goal. Are you getting that? Because these are my actual values. Y-test are my actual values. Okay, these are my predictions. Whether you're using the raw data predictions or scaling predictions, or let's say you use some other scaling techniques, any other scaling techniques, each of these will give you some values. Ultimately, I'm going to choose that technique which will give you maximum similarity with these values. Agree? Getting the points?
Yes, sir.
Okay, so over here, if you see with a simple pred, if I'm using 0, I'm having 1. Okay, here the model predicted wrong. 0, 1 predicted wrong. Okay, here okay, here also predicted wrong. Here also predicted wrong. Predicted wrong. Accuracy is very low without scaling. Getting? But now these are the predictions. These are the predictions from the scale data. Over here, if you see, comparing with y-test. Okay, comparing with y-test, 0, 0, yes. So actual value is 0, model predicted 0, okay, 1, 1, okay, 1, 1, okay. So here 0, 1, here it failed, and 1, 1, it okay. Only one way, one place it has failed. Okay, but the accuracy is maximum. So scaling is increasing the accuracy. How I can say increasing the accuracy? The values are getting closer and closer to the actual data. This is my fundamental agenda. Whatever the values I'm going to get from the model, that should match with my y-test ultimately. Okay, if it is if my y-pred is only matching, for example, let's say in some scenario y-pred is only matching and scaling is not matching. Okay, let's say here everything is matching except 1, here everything is failing except 1, then I will not do scaling at all. Okay, because in that scenario, in that particular scenario, scaling is actually giving worse results due to some reason. Okay, in those cases, I will not do scaling, I will go with the actual values only. So the point is to have the better accuracy. The point is not to do scaling every time. But most of the time, scaling will give us best results. So that's why we'll go with the scaling. Okay, and how you can compare that scaling is working or not? By checking the accuracy. Getting, guys? Getting my point?
Yes, sir.
Yes, Santosh.
Okay, so that's what I'm trying to show here. So this is my normal model. Okay, this normal model y-pred, and the other one is, this is my y-pred scale. Okay, and now if you see the accuracy, okay, when I'm planning the accuracy, you will be checking the accuracy both with the y-test. Agree? So whether it is normal model also or with scale model also, ultimately you need to check with my y-test. That is my ground truth. Okay, so which I was trying to show here. Okay, so that's why if you see over here, my accuracy score also I'm checking this y-pred. Okay, so where am I? See, this y-pred also I'm comparing with y-test. This y-pred scale is also I'm comparing with my y-test. Cool. And this is accuracy. From where you are getting accuracy from sklearn metrics, you can input accuracy score, which we have seen. And if you see the first one, the actual score without any scaling is 0.65, and the scaled data score is 0.86. Getting, guys? And what does this mean? What does this mean? The score is more. That means the values of y-pred, okay, are not that close to y-test. That means if y-test is the thing which I've just explained. You need to think of this. Okay, here the accuracy is 86. That means here the scale accuracy is more. That means whatever the values, the predicted scale values, okay, are very much closer to y-test when compared to the normal without scaling y-pred values. When compared to y-test, we are having only 65, but here 85% of 86 values are getting 86% of the values are getting matched with the y-test. That means these values, y-pred's values, are becoming more and more closer to y-test. Still, it is not 100%. That's fine, but it is at least better than the actual values, the scale values. How did you get this y-pred from here? That means x-test scale you are passing. That means you are using it on model on the scale data. So whenever you are passing the scaled data, scaled values, the accuracy is increasing. That means the output values, the y-pred scale, when you compare with y-test, you are getting better accuracy. Means the values are, whatever the actual values are there, the y-pred scale is also trying to predict almost similar values when compared to the without scaling values. Is it clear, guys?
Yes, Santosh.
Understand the logic? Okay, fine. So I will just show you one more thing. So let's say if you take some other model, okay, instead of logistic regression, if you use some decision tree classifier, okay. So I'm not going into how to do this, but similarly how you have done logistic regression, here also you need to just import one object, and this is simple decision tree, this is scale decision tree, and okay, and you have done training, okay, everything, and on the normal without scaling, with scaling you have done. But the point over here is, if you see the actual value is 0.875 and scale value is also 0.875. This is important. Why? That's what I said. So when you go over here, okay, for the feature engineering, so if you see feature transformation, yeah, feature scaling especially. So over here I mentioned it is important for the models which works with the distance measure. Okay, so logistic regression will work on the distance measure. Okay, it will calculate the distances, and it will, I would say in the algorithm when we study, you will understand it involves a distance measure. So that's why it is having effect. But coming to decision tree model, which we did not study decision tree, but as of now, I'm letting you know that decision tree model, it will be just a form of if else. Okay, I think Meghana and Sirisha might have some idea because they might have all studied. Okay, but it will be just if else conditions. It will divide the whole data into small chunks of data just by asking certain if and else conditions. Okay, there is no distance included. Agree? Do you guys agree, Meghana and Sirisha?
Yes.
Right? So it will just ask some if and else conditions. It will keep on dividing the data unless you get some pure values. Okay, there is no distance involved. So when there is no distance involved, whether you do scaling, whether you don't do scaling, how does it will make a difference? Agree? So that's why here when I pass the scale data also 85, when you don't pass the scale data also it is 85. Okay, so it is always important to first decide which model you are going to use. Okay, based upon that, whether you need to do feature scaling or not will be dependent. Okay, so that's how which you can clearly see when you use a logistic regression, there is a clear effect of scaling where the accuracy is increasing. But if you don't use logistic regression, so some other model which does not depend on distance, the model will have no effect at all on the scaling. You will have the same accuracy. Okay, so this is just describe values. Okay, and if I just show you, yeah, guys, do you have time or 5 minutes?
And 5 minutes is fine, Santosh. Like I need to go to office.
Sorry, 5 minutes is fine, right? Okay, fine.
Yeah.
So just one last point, because we can complete this, and after this I will share this notebook. You can also practice. So till now we have seen, right? So if I just show you one more last point, like whether it is going to affect the outlier. Okay, so intentionally I'm including some outlier values into the age. Okay, that means I'm saying 5, 90, 95, some outliers, and here also I'm adding some outlier values. Okay, and some output values 0, 1, 1. Okay, so now if you see, you are adding 3 outliers. Okay, here also I'm adding some outliers. Fine. So now if you see, I'm plotting, if I plot, so these are my 3 outlier values. Okay, so one is 5, 90 and 95, or 3 outlier values I'm using. Okay, so I've included wantedly just to see whether outlier will have any effect with the scaling or not. Okay, and same thing. So with the outliers, I'm doing the train test split, everything. Okay, but the point here is, when you do before scaling and after scaling, okay, before scaling these are the values, after scaling these are the values, the outliers still remain. You're having only 2 because the other one went into test data. Don't think one we have handled. Okay, so here we are dividing into train data and test data, right? So when you do training and test data, one outlier went into test data. Okay, but here the train data which you are checking, okay, so still the outliers are present. That means, what is the point? The point here is to make that outliers won't get affected by scaling. That means they will not get corrected by scaling. They will still stay as outliers. You need to separately handle them. Okay, when you use standardization, scaling specifically, outliers will not get affected. That means they will still remain as outliers. You need to separately handle those using some techniques. Okay, or first that means first you will handle the outliers, then you will proceed for the scaling. Getting, guys?
Yes, Santosh.
Okay, fine, guys. I would say that's regarding the scaling. So I think we have seen end to end. Okay, this notebook will be very helpful, right from the importing and understanding with scaling, without scaling, with the plotting and the distributions, and with the models, and which model to use, which model to not use, and the effect on the outlier. Okay, so this will be very good exercise for you. So go through this notebook line by line and try to run it by yourself. Okay, I'll share this notebook and this also. Okay, and that should be a very good understanding regarding the standardization of the scaling. Okay, so, and tomorrow we are going, or if possible today evening, let's connect again and discuss on normalization. Okay, so once you understand these two, then you will have a good picture. You can close the topic on the feature scaling, and then you will be comfortable with the scaling next time whenever you hear this word. Okay.
Yeah, also can you please share that Excel as well, Santosh? Like
Which
data.
one? Which Excel? This data set.
Yes.
Yeah, I will share that. Both
Okay.
I will share.
Okay.
Okay.
Yeah.
Are we good, guys? Did you understand today's class?
Yes, Santosh.
Okay. Fine, guys. Oh, cool. So that's all from my end. Thanks.
Thank you.
Yeah, thanks.